right, go ahead and get out your science book and your vocabulary notebook and open to a clean page in the science section of your vocabulary notebook. Today we are going to be going over, excuse me, chapter 9, lesson 3. And of course, you'll write the title of the notes and today's date at the top of your clean page, and make sure that you are reading along with me as I read. So lesson 3 is about classifying matter. Go ahead and open your books to page 430, and let's look at the look and wonder. Read in your head while I read out loud, and be thinking of your answers to these questions. Everything you see in this picture is made of matter. Just as the basic unit of all living things is the cell, matter has a basic unit too. What is that unit? How does it differ among matter? So those are the questions that we're going to be answering in today's lesson. Go ahead and turn the page, and let's read the main idea. All matter is made up of elements that can be classified according to their properties. So this whole lesson is going to be on elements and how they're classified. A lot of science, in almost every chapter we've talked about classification. A lot of science is grouping things together that are alike and keeping things that are very different in different groups. There's a lot of things in this world. And so we need a way, especially scientists need a way to keep them straight and to keep them together so that we know what all of these things are. Classification is a way that we do that. So just like animals and plants are classified, elements are also classified. What are elements? People once thought that all matter was made up of earth, air, fire, and water. That's it, nothing else. We now know that all matter is made of elements. An element is a substance that is made up of only one type of matter. So earth, air, fire, and water are all made of all different kinds of elements. Elements, which is our first word, an element is a substance that is only made of one type of matter. So that means there's only one type of thing in this. It's not made up of a bunch of different things. That's only one thing. Like earth, air, fire, and water are all made up of many different things that come together to create those. Elements are each of those things that are put together to create those. Scientists call elements the building blocks of matter. That is because an element cannot be broken down into a simpler form. Hydrogen and oxygen are elements. So are gold and silver. So that means they can't be broken down any more than they already are. If you get those little pieces of those elements, you can't break them down into anything else. It is just gold, it is just silver, it is just oxygen, it is just hydrogen, and so on. There are many, many, many elements. Atoms. Elements are made up of atoms. An atom is the smallest part of an element. So our next word is atom. And an atom is the smallest part of an element. You can think of atoms as tiny particles, so tiny that you can't see them. I think we've talked about molecules before, or if you've ever seen the episode of The Magic School Bus that's all about molecules, you'll see that they're broken up into, they have to get really, really tiny to be able to see those molecules. where atoms are even tinier because atoms are what make up those molecules. All atoms in an element are alike. For instance, all the atoms in copper are copper atoms. They have different properties from the atoms of any other element. So that means when you get to an element, all of the atoms inside that element are all the same. They are atoms for that element. But if we're talking about air, which has oxygen and nitrogen and, oh gosh, I can't remember right now off the top of my head, but you know it's not just oxygen. Carbon dioxide, all of those things. Each of those atoms, those carbon dioxide atoms, the oxygen atoms, and the nitrogen atoms come together to create our air. But inside the hydrogen, there's only nitrogen atoms. Nitrogen. And inside the oxygen, there's only oxygen atoms. So those come together. Water is made up of hydrogen and oxygen. So that means our water is made up of hydrogen atoms and oxygen atoms. Metals and nonmetals. How do we classify elements? One way is to decide if they are metal or nonmetal. A metal is shiny. It can be bent or hammered into a shape. Some metals are iron, aluminum, and copper. So let's pull the definition out of that. So our next word is metal. So metal is an element that is shiny and can be bent or hammered into a shape. So just like animals, the first thing that scientists look for when they are classifying animals is, are they a vertebrate? Do they have a backbone? Or are they an invertebrate? Do they not have a backbone? So this is one of the first things that scientists look at to classify elements. They look, is it a metal? Is it shiny and it can be bent or hammered into a shape? Or is it a nonmetal? Does it not have these qualifications or these characteristics? And then examples of metals are iron, aluminum, and copper. Metals let heat and electricity pass through them easily. A metal pan over a flame or a heated burner gets hot very quickly. If you've ever cooked, you know that. Metalloids, such as silicone, have some but not all the properties of metals. That means they are kind of like metals, like maybe they are shiny, or maybe they can be bent or hammered into a shape, or maybe heat and electricity pass through them, but they don't have all three. They are not shiny, can be bent or hammered into a shape, and they cannot, heat and electricity don't pass through them. So those would be metalloids. They meet some of the qualifications, but not all of them. Oxygen and nitrogen are nonmetals. They have none of the properties of metals. They are gases. So they don't have any of this stuff. So we have metals, which have all of these characteristics, metalloids, which have some but not all, and then nonmetals, which have none. If we look at these, the pictures around pages 432 and 433, we see examples of different metals and nonmetals. So if you look at the bottom of page 432, there's a fish, a picture of a fish, and it's a sign. It says neon is a gas. In a tube, neon glows if electricity is added. So neon, you've seen neon lights everywhere, like on signs, on the open signs, all of those things. That's neon. So neon is actually a gas that's inside of those tubes. And when you add electricity, it glows. That's why you still have to plug in neon signs. At the top of page 432 and 433, we have a bat, and it's aluminum, and it says aluminum is strong and light in weight. So it is a metal. It has these qualifications, but it's a metal that is strong and light. Not all metal is strong and light. You may think of something metal, like, I'm trying to think of something. Say you have a fancy weights. They're usually made of a really heavy metal. An aluminum bat is not like that at all. So even though they are both metals, they still have different characteristics. Then if we look down here, where we have the jewelry, right above it we have this kind of weird shaped reddish thing. This is a piece of pure copper. So we know copper, we think of pennies as being made of copper, even though I don't think that they are anymore, but they were at one time. This is what pure copper looks like. And then right underneath, we see that an artist has used copper to make jewelry. That's one of the traits of metal, is that you can bend it and hammer it into a shape. So they took this piece of pure copper that looks kind of like, almost like maybe a coral, and they turned it into this jewelry right underneath it. Symbols for elements. Scientists use symbols to stand for each element. Often, a symbol is the first letter of the element's name. For example, C is the symbol for carbon. Some elements take their symbols from their Latin names. The Latin word for gold is aurum. Gold symbol is AU. The first letter in a chemical symbol is always capitalized, and we will see that on the next page when we look at the periodic table of elements. That is a table of every known element. It would be much too long to write the name of each element out every single time, especially if we're trying to talk about the names of the elements inside of a substance that is made up of more than one. So they use those symbols instead of having to write out the full word every time. Now let's look at the quick check at the bottom. Now this is where you are going to listen to the question, pause the video, write it in your notebook right underneath the third definition, and then play the video and check your answer. You may use your pencil to fix it if you need to. Okay, the first one is about classifying. Name 2 elements that are gases. Name 2 elements that are metals. You can find all of those answers on these 2 pages. So you're naming 2 elements that are gases. Write them in your notebook. You don't have to write complete sentences. Just make sure that you indicate gases, this, and metals, this and this. Some possible answers that were on these pages for gases: oxygen, nitrogen, neon. Let's see, they named some other one. They named hydrogen. They didn't tell us it was a gas, but it is an example of a gas. So those are some options that we saw on this page. Now for metals, they mentioned iron, aluminum, and copper. Let me see. They also mentioned gold and silver. They didn't tell us that they were metals, but if you think about it, they do have these traits that we talked about. Okay, now the critical thinking question. Table salt is made of 2 elements, sodium and chlorine. Is table salt an element? Why or why not? So make sure you answer, is table salt an element, yes or no? And why or why not? So the answer is no, table salt is a compound that contains 2 separate or different elements. An element is a substance that is made up of only one type of matter. So salt is not, because it's made up of 2 types. It's made up of sodium and chlorine. So therefore it is a compound, not an element. Go ahead and turn to page 434 and then read with me while I read out loud. How are elements organized? Nearly 150 years ago, a Russian a Russian scientist named Mendeleev made a table of the elements. He based his table on the known property of elements. It is the periodic table. What that means, basing his table on the known properties of elements, means we don't know all the properties. We don't know what all the elements are. So it's just based on the properties that they knew of 150 years ago. Now those things may have changed, but we were able to add different things to the periodic table, and when we look at the diagram at the top, we'll kind of see what we mean by that. So our last vocabulary word, our last vocabulary word is periodic table. And the periodic table is a table based on the known properties of elements. So that means it's organized based on what we know about the elements. Atomic number. As new elements were found, they were added to the table. The modern table is shown above. So the table at the periodic table at the top of this page is the one that we have now. This is not the one that Mendeleev created because there weren't as many elements. In fact, I think because this science book is a little bit older, I think there are quite a few that have been added even since this periodic table was printed in this book. The three main groups are metals, metalloids, and nonmetals. And we just talked about that. We talked about how metals have all of these properties, plus they can be heat and electricity can pass through them quickly. Metalloids are elements that have some of these properties of metals, but not all. And then we have nonmetals, which don't have any of these properties. You can see that the elements are arranged by their atomic numbers. The atomic number is related to the mass of each element. So that atomic number is based on the the grams in the element. Is it heavier or is it lighter? Not the weight. Remember, weight is different, but the mass. Does it have more matter in it or does it have less matter in it? Columns and rows. So far, scientists have named 112 elements. I think that has changed. You know what? I'm going to Google it really quick, and I'm going to see how many elements there are today. How many elements are there on the periodic table? There's 118. So, since this textbook was, let's see if I can see what they are. Since this textbook was printed, they have added 6 elements. Let's see. I'm trying to do this quickly so that I don't take a lot of time. Let's see. Okay, I can't find them right now, but if you want to, you can Google that and just Google what are the newest elements. The periodic table shows how they are similar and how they are different. Elements in the same column have similar properties. So if you're looking at the columns, remember the columns go up and down. Like think of a building. If a building has columns, it's holding up the roof. If the columns were sideways, that wouldn't do very much. And then if you're planting things, you're going to plant it in rows, which means side by side. If you planted the seeds right on top of each other like a column, they wouldn't grow very well. Maybe only the top one would grow. For example, all the elements in column 17 combine easily with other elements. So find column 17 at the top. It's the second from the last column. And we see fluorine, chlorine, bromine, iodine, and astatine. Those are elements that combine easily with others. They often form new substances. The elements in column 18 hardly ever react. So that means if you find column 18, which is the last one, if you do things to those, like you add them to other substances, or if you heat them up or cool them down or do something like that, try to change them in some way, they don't really do much. The rows of the columns are called periods. Remember, rows are the side to side. They also group similar elements. Iron, cobalt, and nickel are magnetic. They are next to each other on the table. So let's find iron, cobalt, and nickel. They should be in the same row. And that means everything else that's in that row with them are also magnetic. So if you go to the fourth row from the top, where hydrogen is the first, and then we have lithium, which is the second, sodium, which is the third, and then potassium, which is the fourth row, or period. That's where we will see iron, cobalt, nickel, and iron, cobalt, and nickel. And they are right next to each other because they are very similar. They are all magnetic. So let's look at this periodic table. Make sure you pay attention to this because you might see it you might see it later today. Hint, hint. So we see this periodic table at the top of pages 434 and 435. We know that the columns, which go up and down, all share similar properties, and we know that each row each row groups similar elements. Another name for each row is its period. So what I want you to do, we're going to look at this Rita table. What is the atomic number for fluorine? Which is the symbol for that is F. Is it a metal? What state is it at room temperature? So this is where you need to look at the key. So the key tells us that the colors of the boxes tell us if it is a metal, a metalloid, or a non-metal. All of the purple elements are metals. So we have mostly metals. Most of our elements are metals. Then we have the yellow, which are metalloids. That means they share some properties of metals, but not the same. We have the least amount of metalloids. And then we have the green, which are non-metals. So that means anything in green has no properties of metal. The color of the writing tells us, is it a solid, which is black, a liquid, which I think is like blue or purple, maybe blue, or a gas, which is orange. So let's find fluorine, and we're going to say, is it metal, which means it would have to be purple, and what state is it? What color is the symbol in? Is it black, blue, or orange? So let's find fluorine. Oh, I see it. It is in column 17, so find column 17 in the second period, which means the second row. So find column 17, find the second row, and you'll see fluorine. Well, fluorine, the box is green, so that means it is a non-metal. The symbol for it, the F, is orange or reddish, so that means it is a gas. So that's how you can figure out what are the metals, what are the metals, non-metals, or metalloids, and what state are they in. Are they a solid? Are they a liquid? Are they a gas? Let's look at this picture at the bottom of page 435. Read the caption with me. Diamonds, coal, and the graphite in pencils are all made of carbon. Ooh, let's do that same thing we did with fluorine with carbon. So, they are not only made of carbon. They are compounds, which means carbon mixes with atoms of other elements to create diamonds, coal, and graphite. So what that looks like. Say we have a chunk of gold. It has all gold particles in it. Now, say we have a substance, oh gosh, I should have thought of something. I can't think of a substance that's made with gold. Oh no, you know what, I'm going to go back, ignore that. I'm sorry. I'm going to go back. Let's think of table salt. So we know table salt, based on the critical thinking question on the page before, we know that table salt is made up, go ahead and write this and then draw the picture. Table salt is made up of sodium and chlorine. Sodium's particles, this is not what they actually look like, but we will represent them as plus signs. So the sodium particles, so if we have a piece of sodium, it is made entirely of sodium atoms. Sodium looks like this. The atomic symbol, or I'm sorry, the symbol for sodium is Na. And now if we have some chlorine, its particles look like, we'll do circles, this. So this is just chlorine. The the symbol for chlorine is Cl. So we have some sodium and we have some chlorine. If we put these elements together, it equals table salt, which if you look at table salt, is a compound because it has atoms of both sodium and chlorine together. That's the same as diamonds, coal, and graphite. They are made of carbon along with other elements to create this compound. Now, let's do what we did with fluorine with carbon. So let's find carbon in the periodic table, and we're going to say, is it a metal, metalloid, or nonmetal? And is it a solid, liquid, or gas at room temperature? Go ahead and take a second to find carbon. I found it. It is in column 14 in the second period, which means the second row. Its symbol is C. And once you find it, you can see that the box is green, which means just like fluorine, it is also a nonmetal. But the writing, the symbol is black, which means it is a solid at room temperature. Fluorine is a gas at room temperature. Carbon is a solid at room temperature. If we look at this, we can see there are only let's see, 2 elements that are liquids at room temperature. And it's bromine, which has an atomic number of 35. The atomic number starts at 1, and then 2, 3, 4. Look at that atomic number. That's the number that's right above the symbol. So let's see, the element with the atomic number of 35, bromine, is a liquid, and the element with an atomic number of 80, which is mercury, is also a liquid, and those are the only liquids that I can see. Now maybe some of those new elements are liquids. I'm not sure. If you want to Google that, go right ahead. Okay, now let's do the quick check at the bottom of page 35. So remember, what you're going to do is I'm going to read the question. You're going to pause this video, write your answer, play it, and check your answer. So the classify question. Describe how the periodic table is organized. Okay, so you may have something different. Just make sure, because the answers will be different depending on which parts of this you chose to write about. So a possible answer is elements in the periodic table are grouped together based on their properties. Now you may have gotten a little more specific by saying that you may have gotten a little more specific, but that's the general answer, that they are grouped together based on their properties. Now the critical thinking question. How are coal and diamonds similar? How are they different? So you need to answer both of those questions. So diamonds and coal are similar because they're both made of carbon. They both have carbon in them. They are different because of what those carbon atoms are joined with, how they are joined. Are they joined, which other elements are joined together to create those compounds? Okay, go ahead and turn the page 436, and then read with me. How do scientists use the periodic table? When Mendeleev arranged the elements in a table, he saw a pattern. Elements with similar properties were grouped near one another. Scientists use these patterns to predict how an element behaves. Hydrogen, for instance, reacts easily with other substances. That means if you put hydrogen with other elements, it's going to change or react very easily. The elements that share its column in the periodic table also react easily. So that means everything in the very first column reacts very easily. We just read that everything in that very last column, column 18, doesn't react easily. So they're really far apart. Elements that share the same row often have similar properties too. Iron, which symbol is Fe, is magnetic. Can you find it in the table? The two elements next to iron are magnetic too. So what I want you to do now is go back to the periodic table, find iron. Remember, its symbol is Fe. And then look at the next two elements. They're all magnetic. Turn back to the periodic table on the previous page. You can see that some parts of the table are not filled in all the way. Why not? It's because scientists have not yet found all the elements they have predicted. So if you go back, you'll see that numbers 114, 116, and 118 are not filled in. That's because they know that they're out there, but they haven't actually found it yet. They've predicted that there are elements that would go in those places, but they don't know what they are yet. Some of these I think number 118 for sure is one of the ones that have been discovered since this textbook was published. Now, let's look at this diagram on the side on page 436. Pay attention because you may see it in a little bit. This diagram compares the properties of elements. So if we look at the top with the picture of the banana, we see that it says, bananas have lots of potassium. The symbol for potassium is K. Elements in the potassium column react with nonmetals. So that means if you go back to the periodic table and you find the column that has potassium in it, we don't have to do that right now because it's right here, all of those other elements in that column also react with nonmetals. That means if you try to create a compound with potassium and one of those elements that is a nonmetal, they're going to react or change. That potassium is going to react or change very easily. It's going to be able to become something else pretty easily. Now, if we look at the box that has the picture of the nails, many nails are made of iron. Its symbol is Fe. Cobalt, symbol Co, or nickel, the symbol Ni. These elements are all magnetic. This is the third time we've talked about these magnetic elements. So they really want us to know that iron, cobalt, and nickel are magnetic. And they are right next to each other. We can see in this little picture that they pulled from the periodic table that they are right next to each other. They have the atomic numbers 26, 27, and 28, which means they're right next to each other. And they share the property that they are magnetic. Now at the bottom, we have this kind of crystal-looking thing, and it says, this is a sample of fluorine, or F. All the elements in the fluorine column form salts with elements in column 1. That means if you take all those nonmetals that are in the same column as fluorine, which I think is number 17, and you mix them with an element that is in the very first column, it is very easy to create salts. Now, not all salt is table salt that we eat, but salts are another type of, they're a type of compound. You can Google what that means exactly. So let's look at that because I bet we might be able to see how sodium and chlorine mix together easily because I bet one of them is in column 1 and one of them is in column 17. So if we look at column 1, let's see if we can find sodium or chlorine, which means we're looking for Na or Cl. And in column 1, we can find Na for sodium. Now let's go to 17 and see if we see chlorine, the Cl. And column 17 does have chlorine. So we just read that elements in column 17 with fluorine can easily create, can form salts with the elements from column 1. Chlorine's in column 17 with fluorine. Sodium is in column 1. And they do come together to form table salt. Now, let's look at this Rita diagram. Which elements are magnetic? Which elements form salts? Well, we know that the elements iron, cobalt, and nickel are magnetic because this diagram tells us. And we know that the elements in column 17 and the elements in column 1 can mix together to form salts. You may have some more questions on it when we get to the independent practice. But before we get to that, let's do the quick check at the bottom of page 436. Remember, as soon as I read the question, pause, answer the question in your notebook, play, and check. So the classify question. How do scientists use properties to classify elements? And the answer is, elements that have similar properties are grouped near each other. So what we do know is that everything in each column has a similar property. You may just have to look up what that property is. And we know that most things in the rows are have the same properties. Not exactly the same, but similar. The critical thinking question. Why might a scientist want to make a prediction about an element? You may have a different answer. This is critical thinking. That means it comes from your brain, not necessarily the book. But one possible answer is they want to test how elements react with other elements. They also want to be safe while doing experiments. They need to make sure that an element, they need to know that classification and they need to make predictions, because if they try to mix an element that is very reactive with another element that is very reactive, bad things could potentially happen. Okay, so now that we're done reading, if you need to go back and listen to any of this, because I know some of it was a little confusing, go ahead and do that. When you're ready, go ahead and get out today's packet for, oops, I grabbed the wrong one. Hold on one second. Here we go. The packet for Friday, March 27th. You'll open it up to the first page, and you'll see page 1 of your independent practice. It's one of those diagram sheets. Make sure you do the front and the back. Remember, the answers can come either from the diagram, which each one has written where a better version is, or they might be from the book, but usually you'll find the answers around where these diagrams are in the textbook. As soon as you're finished with that, you may go ahead and start on the homework, or you can wait to do that later today. That's up to you. Okay, that's it for science for chapter 11. Now, we are not having a test on science on Monday. Monday is where there will be no science video either. On Monday, what I want you to do is be looking through your book, be looking at your vocabulary, and get ready for this test. If you have any questions about anything we talked about in chapter 11, no, I'm sorry, not chapter 11, chapter 9, please ask me during that time, during my office hours between 1 and 5. Then on Wednesday, you will take your science test between 1 and 5, so that if you have any questions, you can ask me. Remember, during your science test, you may use your book and you may use your notes. However, you cannot ask your parents or siblings, and you can ask me to clarify questions. But remember, this is to show your knowledge, what you learned about chapter 9. Okay, so today's the last lesson, the last video lesson for chapter 9. On Monday, if you have any questions while you're studying, please ask me. Please Skype me or FaceTime me, and then on Wednesday you will take your test.